Today we have 3 finalists from the Google Science Fair whose inventions are sure to inspire you.
And we're going to meet with 3 young scientists who are going to help us kick off Science and Technology Week. And we're going to meet a guest maker that will change how you think about medicine.
So let's get ready to make something great.
Thank you for joining us. I'm Camp Director Paloma.
And I'm Camp Director Sam.
And you know what? We're going to meet with some amazing people from the Google Science Fair, which is a global online science fair that focuses on science and technology. It's open to individuals and teams from 13 to 18, and there are thousands of entries. So we're going to go ahead and meet some contestants who are finalists in the science fair. We have Arsh, we have Mihir Garmela, and Myrijam Stutzer. So thank you so much for joining us in Maker Camp.
Hi, thanks for having us.
Great to be part of Maker Camp.
Glad to have you guys here. Why don't we start off with some short descriptions of each one of your projects? And Mihir, why don't you just start off talking about your work?
Sure. So essentially, I created a really lightweight method of evading moving threats in a flying robot by drawing inspiration from what fruit flies do to escape when you try to swat them. And so my ultimate goal was to make flight for things like robot-assisted search and rescue missions or emergency response really autonomous and scalable, so it can be done in a lot of places at the same time. And so just a little bit of background, fruit flies are sort of really good at escaping from threats like swatters really quickly. And so they actually, like about 200 milliseconds before they escape, they sort of perform all these calculations and adjustments to determine how the threat is approaching and how best to escape. And so they also do this despite a really, really limited visual system and a really simple brain that can't do very much. And so that's sort of something I tried to mimic. And so this is sort of what I came up with. This is a really small flying robot. And then I built the sensor module on the bottom. So you can see there's one sensor here and another sensor on the bottom. And basically, to design this, I sort of had a couple of goals. The first was to make it as lightweight, physically lightweight as possible, because flying robots like this, especially the platform that I used, can't carry very much because it takes a lot of power to be able to do that, and they simply don't have that. And so I wanted to make my sensors really, really lightweight as lightweight as possible. I also wanted them to produce very little data. So using traditional approaches use things like cameras or like the Microsoft Kinect and things like that to be able to understand the environment. And while that's really great because you get so much information, it's really hard to process all that and react in real time. And so I wanted my approach to sort of buck that trend and use these really simple sensors that can still be really effective. And so as I said, in the end, I sort of came up with the sensor module, and I think we have a more detailed picture of that. But basically, I sort of came up with the sensor module. Yeah, there's the picture. And so I sort of came up with the sensor module and mounted it on the quad rotor. And the sensor module tries to sort of understand how threats are approaching, and then based on that, react. And then I also designed algorithms to sort of map the trajectory of approaching threats and then follow this segmented escape sequence that's shown here to be able to escape effectively. And so basically, to sort of verify the effectiveness of my algorithms, I performed these 20 different trials using this sheet of plywood. And so I basically tried to simulate a collapsing ceiling or something that's falling, and tried to see how my quadcopter would react. And so it escaped successfully in all 20 of those attempts, which was really exciting. And then I think it was shown there a second ago, but I sort of took frames from a video of one of my escapes and compared them to frames of a video of fruit fly escape to see that, to sort of verify that I was able to effectively mimic what fruit flies do. And so I concluded that my algorithms were really effective despite having limited sensing. So they don't know a ton, but they're still really effective at escaping from threats. So that's a bit about my project. And I think we actually have a slow motion video of my robot escaping from a threat. So as the threat approaches, the robot sort of moves sideways away from the threat, and then it moves up to complete its the final segment of its escape.
Wow, that's really impressive.
Thank you. So that's a bit about my project.
Thank you so much for sharing it. Wow, that's such a really amazing project, and I can't wait to hear more about it too. But I know that we also want to introduce some of the other people that are with us. So Arsh, why don't you tell us a little bit about your project?
So, hi, first of all, thanks for having me on the show. And for my project, I'll throw a little background on what an AAC device is. People like Stephen Hawking who are suffering from disorders like locked-in syndrome, motor neuron diseases, so they cannot communicate because they're fully paralyzed, neither can they speak using the normal form of speech. So they have to use an augmentative and assistive technology to communicate. Current technologies, what they do is, there's a matrix of letter. So there's a box, for instance, on B. The person can twitch a muscle. So B is selected. When the switch goes high by the muscle twitched, and then the box cycles through all the letters and comes back at A, and the person again twitches, then A is selected. So that's how they communicate. And it's really tedious project, really tedious process, and it takes quite some time to even make out simple words. The technology hasn't changed since the past 10 years, and I decided to do something for it. So out of that whole process, out of that whole inspiration to change something, I came up with Talk. And before giving an introduction, I'd like to roll a video that we have here, just demonstrating some basic usage of Talk, how it can be used. So can we have the video, please?
Talk simply requires the user to give two distinguishable exhales, either from nose or mouth, which are interpreted as Morse code and converted into sentences and phrases.
Talk is an innovative art device for people with developmental disabilities.
And with features like command mode and encoding, it couldn't be easier to use. With the help of command mode, user can customize a set of commands corresponding to each letter, like W for water. And using encoding in normal mode, a user can reduce common sentences like hello, how are you, to edge.
So that was a video demonstrating what Talk is. So the user has to give short or long bursts from the nose, which a person does thousands of times a day, and no one just noticed it. And I believe the fact no one noticed it is breath. It has been rooted so much into our bodies that we don't even remember that we are breathing. It's quite weird to think about, though. So I used breath. So there's a sensor placed into the nose, which takes in breath, distinguishes it as long bursts, short bursts, separates it out from the surrounding noises, the hums around the physical noise of the ear clip moving and things like that. They're then converted into Morse code and synthesized accordingly. The benefit of Talk, why Talk is better than others, is we've taken something which used to fit on a wheelchair, required big screens, big batteries, and computers, put that into a size of a box this small, and reduced the manufacturing cost by a factor of 20, which I believe is quite incredible. This puts Talk, an AAC device, in the reach of everyone. Earlier AAC devices weren't quite affordable, so to actually help people, to benefit people, Talk is one of those things. It is one of the world's first and only wearable AAC device for people who are almost entirely paralyzed. So that's Talk. And another fun part about Talk is it has really cool features like encoding. So in daily routine, we use sentences like, hello, how are you, when we meet a person, or like, okay, talk to you later. So those sentences, instead of the long ones, can be jotted down to simple words, like HH for hello, how are you, as just shown in the video. And there is a command mode, wherein if you were to see a doctor and you have some particular problems, like you usually have headaches, you have chest pains, you have abdominal pains, so you can encode them to particular letters. So for abdominal pain, you'll just have to dictate out A, which takes only 0.8 seconds, so you don't have to go through the abdominal pain thing. It's also better because breath, it's so easy to use. And not only breath, even the persons who've got through tracheotomy surgery can sniff out air using their mouth, so you can use mouth. The versatility of the device, the portability, and the affordability of the device really makes it unique as compared to the other things out there. And as for talk, I have two versions of talk. One is the box-like feature, which the person can actually use, and the other one is the development kit, wherein I've developed a specific Morse engine, which takes in the input from the sensor and then synthesizes it. And the most difficult part about making talk was to come up with a way so that we can take input from the breath, not a pressure sensor, because I don't want anything to go inside the body of the person, take the input from the breath, and then distinguish it as long burst, short burst, noises from the surroundings, people talking, and the worst part of all, if you have an oversealing fan. That just ruins it all. It just throws everything apart. So you cannot use normal high and low switches as we do in some of our equalizer Arduino projects wherein we blink LEDs according to the music. Neither I can take and build a voice recognition processing system because I want the processor to be small, affordable, and compact. So to find a sweet spot between both, wherein you take the best of both, you take the best of ons and off, you take the best of voice recognition, and put that into a code, an engine, which can fit into a small device that has memory of less than a megabyte, that was quite an incredible challenge to overcome. So in the process, I came up with talk, and let's add some fun to it. Okay, so campers, I'm waiting for a word or a phrase from you, and I'm going to synthesize that using talk right now. How about that?
That's awesome. And you know what? Let's do that in a minute because I really want to get
So, can I have the word, please?
You know what? Let's get back to that in a minute because I know I really also want to hear what Myrijam has too because I know Myrijam is working on some great stuff. So Myrijam, can you tell us a little bit about your project?
Yes, of course. I'm really proud to be here. And my project is a pulse sensor for virtual jogging in Google Street View. And the pulse sensor recognizes with infrared light changings of our skin when the blood comes through the arteries from the heart bumps, heart moves. Yes. It is also called pulse oximetry, and it is used professionally in hospitals. Yeah, and you can clip the pulse sensor on your ear, and then you can jog in front of a computer on Google Street View, and in Google Street View the virtual option moves ahead because a motor types the cursor up key in the distance of 3 or 4 heartbeats. Otherwise, it is like walking with 7 miles boots on. So the impression of jogging in a real environment is generated just through the body feedback.
That's such a great idea. I love that, and I can't imagine like how you did that. Please tell us more about it.
How did I came to the idea to do my project, or?
Yes, please tell us about how you came up with the idea.
Okay, I moved from Berlin to Duisburg. It's in North Rhine-Westphalia. It was 3 years ago, and of course I'm missing my friends still. And I get down to the idea to jog through the paths virtual. We walk together, and in the robotic club after the school, we are building models with Lego Mindstorms, and it's cool. But I wanted to do something else, and then I came to the idea. And at first I soldered a a platine, a car. Yes, and then it doesn't work because the reflected light it stopped the sensor, and then I
You know,
then
the best thing about this is I can totally just absolutely hear your passion for this project. It's such a great idea. I never would have thought of that.
Oh, that's good stuff.
And I love that you used Lego and Lego NXT to interface with your heartbeats to go through Google Street View. That's such a great idea, and thank you so much for bringing this idea to us. And I also really want to hear more about it in a minute because, oh gosh, so cool, so cool. But first, let's go back over to Arsh. And Arsh, also, I just want to tell you that I really appreciate this project. I know that I know people that are going through lockdown syndrome, and it's a really challenging thing. And your solution is very elegant and simple. So I'd love to see a demonstration and have you talk with us a little bit about your inspiration and about how, you know, a little bit more about how you actually accomplish this.
Okay.
So, talk started, you know, I saw Stephen Hawking. The person, he is, I would say, the greatest scientist of the millennia. What he has given to the world is quite astonishingly large, as I would say it. So, taking that inspiration, he was my inspiration. If given the right tools, if we can do that for the world, there are many people who still cannot afford that technology. Why not make it accessible to all? Why not take the technology of the 21st century, take it from a wheelchair, put it down into a little box, 3D print it, and let's make it available for everyone. So that was the main idea. Let's make the technology reach all from the simple resources we everyone have. So that's how talk started. And then after doing some research, I had to come up with an effective way of actually making interaction possible with the user and the device. So I went through everything from brain-computer interfaces to tongue touch, and finally settled with something we all just missed out: breath. It was so intuitive to use breath that I myself was astonished. Okay, how did I think about that? So after coming up with breath, the next step was finding the right way of using breath. You cannot just use the inhales and exhales. You have to make a person give out something specific. Then came in the Morse code. Morse code is special because it has the more frequently used letters trimmed down. For instance, E is having only one signal as compared to X, which has 4 signals. So that was kind of a plus point of using Morse code. And after deciding that, the next major step was actually looking for the sensor to use. It's really important to find the right way to sense the breath. I didn't want the person to be uncomfortable using the device, so I couldn't use a pressure sensor that could go inside the nose, as used by most of the doctors. So my first approach was an electret microphone. I hope you can see it. It's a simple condenser microphone, which is quite easily available at any of the hobbyist shops. But the problem with this thing was it was too sensitive to any noise around. Not only breath, even if the person hummed, that was taken as a signal. So that wasn't quite possible. I then went on to something quite recent called an MEMS microphone. So it's a micro-electrical mechanical system microphone, and it's quite sensitive to the quite nearby sounds and reads them pretty accurately in the given frequency range. After having done that, I had to decide some kind of a way to take all of those processing and put it down into a really small circuit. For that, the best thing is an Arduino. So I went out with a little sketch of the small Arduino Pro Mini and added some voice synthesization circuits to it. So what the device does is it takes the signal from the sensor. Those analog signals are then sent to the Arduino. Arduino was the first prototype. Now it's more of the required thing. So only the system needed inside it. which is then processed using a Morse engine specifically designed for this purpose, as I talked previously about a sweet spot between the frequency and voice recognition. So the Morse engine converts that into dots and dashes, deleting out all the noise. Those dots and dashes are then converted into letters, sentences, and those sentences are then converted into phonemes, which are the sounds we use for synthesization, and those phonemes are then synthesized. So that's the whole working, from taking something to breath, converting into electrical signals, and sending out the sound signals. So that's how talk works. And I have some 3D printed iterations of talk right now on my desk. So these are some of the first prototypes. The one prototype, the major prototype, which is 100% working, is right now being tested by a user. He's suffering from Parkinson's disease. I cannot reveal out the name for some purposes. So I also have a development kit, which I use for developing the algorithm, as you cannot take the algorithm and compile it every time and port it to the microcontroller or the microprocessor you're using. It's really tedious, and you lose the sense of creativity down the road. So it takes direct signals from the nose, sends them to the computer, so it's all processed on my Mac and computed. Same algorithm is used on the top, which fits in enclosures like these. And I also have an ear clip iteration. So this thing fits on the ear of the person, right like that. That's where the sensor comes down to the nose, and that's how it works. So this is Talk, my Google Science Fair project.
Yeah, that's great. So can we see a demonstration like you were talking about before, using talking to be able to
definitely. Just give me a second. Just
Sure.
give me a second. I'll run up the code. So we have the code working. I'll be staring off from the camera for a while, so I may act a bit weird. Just don't take it otherwise, okay? So moving on, we'll be synthesizing a really simple word, I would say. Making is fun. It really is. So let's synthesize making is fun. Okay? Is that good?
Yeah, great.
Okay, let's do it. So first off, the great thing about the sensor is it only is sensitive to the breath. So I'm going to synthesize M-A-K-I-N-G. It may take a bit of a while. So for M. So now making is in the system. It has taken all the letters for making correctly, and I'm going to synthesize that now.
Making.
I hope you got that.
Yeah, wow, that's impressive. And
So
you know,
now,
if you think about comparing that to how long it would take to go all the way around, pick a letter, all the way around, pick a letter, that's incredibly fast.
that's the thing about talk. Other devices, the person is actually in control of the device. It has to wait for the device to respond the right way. But in case of talk, the relationship is the other way. The person who's using it is actually controlling the device. And that's what makes it unique.
Good stuff. I'm glad that you're making that for people out there who really do need it. Now, Mihir, you were talking earlier about some fruit fly escape algorithms that you came up with for your drones. Could you walk us through how you came up with some of the prototypes that led you to the final version?
Sure, I can definitely. I mean, I went through a lot of prototypes, so I can definitely talk about that. So as I mentioned, my project was sort of divided into two parts. The first was coming up with a sensing solution that could sort of allow my my robot to understand how a threat is approaching in order to best escape. And so initially, like as shown here, I have two sensors, and they're arranged in a certain way, and they try to sense the position and orientation of an approaching threat. And so initially, I think I wanted to have 4 sensors. I also wanted to put a really small Arduino, if you're familiar with that, on board, and an extra battery. But I realized I simply couldn't do that because this quadrotor couldn't carry more than, I think, 10 grams. And so I had to sort of come up with a really lightweight method of still getting the data I wanted. So I sort of used these 2 sensors, and then I'm trying to actually use the onboard battery. That's right here. So it doesn't have a ton of capacity, but I took a lot of considerations for power draw and tried to make the sensor module as feasible as possible. So that's sort of like one prototype. And then the second is sort of designing an escape algorithm. So initially, I sort of had this really naive escape algorithm where as soon as it saw anything overhead within, I think, like 70 centimeters, it would just escape. And I guess that sort of worked in some cases, but it escaped identically to things that were really quickly approaching, like a collapsing ceiling or something falling, into things that were just like moving overhead that weren't actually a threat. And so I sort of had to come up with a bunch of other alternatives and see which ones I could use. And that was especially hard because another thing about quad rotors, and especially the one that I use, is that they don't have a lot of computational power because all of like their computing stuff is done on board. And so they can't process a lot of data. They can't crunch a lot of numbers. And so I sort of had to come up with like a really lightweight algorithm for doing that. And so it actually sort of tries to understand how the threat is approaching, map its trajectory over time, and then decide how to best escape. And so I can actually show a quick demo here.
Yeah, let's see it.
So all of the algorithms, as I mentioned, are being run on the quadcopter itself. I'm just like using my computer as sort of an emergency stop. Once I switch it on, and then let me know if you can see this. Can you see the quad rotor?
I think you have to go down, or maybe move it a little towards the chairs, and then it'll be better in frame.
Wait, is this a little bit better?
Oh, that's great.
Awesome.
Okay, so it might go out of the frame now, but that's, I guess, fine. So once I sort of start software, takes a couple seconds to connect, and then once that's done, it'll start to sort of look for approaching threats, and then based on that, decide how to escape. So did I switch it on? Oh. Right, so it's now connected, and so as this thread sort of approaches, it starts to move away.
Oh, that's wonderful.
It's so quick in its response. That's great.
Right, so I guess my goal was to sort of be able to escape within milliseconds, as sort of fruit flies have to do, and so I was able to conclude that that's something that I accomplished. So I was really excited by that.
Yeah, that is such a cool project, and I can just already think of so many great applications for it. So thank you so much for sharing that with us, and I'm sure it's going to inspire a lot of campers to also follow their awesome, interesting, weird, and cool passions. And I would really love to go back and talk to you, Myrijam, about your project again, because it's so cool and it's so awesome. And so I think you have a video that we can check out about this. Oh, sorry, you're muted. So just go ahead and click the little microphone. Awesome. Okay. So.
Okay. I would really like to present my project live, but I'm in Sweden and I'm on holiday, so I didn't have my project with me. So, but in the video I'm presenting it, but just active, not with words.
Okay, great. So let's take a look at that video.
Okay.
Looks very cool. And so you're using the Lego NXT, and you can see that in there.
Yes, but later on I used the EFO 3. This is a magnet, and it's like a trick. You put it on this side, and it is on, so it realize it. If not, not.
That's a great idea.
Thank
So what
you.
are we looking at here?
This is the brick with the house around the sensor and a motor who's typing the cursor up key.
That looks great. Wow, that's so cool. And it's so responsive.
If I go faster, the pulse moves on, and in Google Street View, the virtual option goes ahead faster too.
Yeah, wow, I could totally tell that your heartbeat's getting faster, so it's moving faster. Wow, great job. So, can you tell us how did you do that? Like, how did you use Legos to actually tap a key?
It's simple, like in the program you use a motor block and you tell maybe 15 degrees like that. I'm not a native speaker, so my English isn't so good.
Oh, your English is fantastic.
Thank you. Where was I?
So you turn the motor 15 degrees and actually tap. And so how do you tell the Legos, how do you get the heartbeat to turn into a motor movement?
It's I can explain the photos, maybe that can help. This is the sensor I bought after then, because the other sensor doesn't work, and you can clip it on your ear and it realize it with infrared light, and yes.
Oh, that's great. I wouldn't have thought that infrared light would do that, but yeah, that's interesting. And what's this that we're looking at?
That are the data plans, I think. I don't know what it means in English. And you see two hard moves, and it's from the AD one, from the
So like each one of those spikes is a heartbeat, and so the
yes,
computer can tell that your heart went.
yes.
Oh, great!
There's another picture where the computer realizes it, and yes.
Yeah, wow. Oh, here we go. I think this is what you were talking about.
Yes.
Okay, so it
Here,
takes the crazy signal and turns it into high, low, high, low.
yes. It's
That's
like yes,
great.
no.
That looks
Yeah.
so wonderful. I thank you so much for sharing that. It's such a great project and it's so interesting and innovative. You did such a good job. Oh my gosh, so cool. So thank
Thank
you
you.
so much for telling us about that. And Sam, I
Good
think
stuff.
we
I've
have
played
an
around
awesome
with
guest.
some heartbeat sensing myself, and you've done it better than I did, so very well
Thank
done.
you.
You earned it. And also joining us, we have the 2012 winner of the Google Science Fair, Brittany Wegner. So, Brittany, welcome.
Hi, Brittany. Oh,
Thanks so much for having me.
yay! We are so happy to have you. So, Brittany, can you tell us what was your project and what have you been doing since then?
So what I did is back in when I was a 10th grader, so that would put me around 15, my cousin was actually diagnosed with breast cancer. So I got really inspired to join the fight in working with breast cancer. I'm sorry, is my camera frozen on your screen?
Yeah, it is, but we can hear you perfectly fine. So while we're waiting for the internet to fix itself, please keep telling us because we are listening.
Okay, so essentially, the idea was artificial neural networks are these incredible programs that can literally transcend human knowledge, and they can identify very subtle patterns in data. So I wanted to see if I could code an artificial neural network that could help doctors improve the diagnostics of breast cancer. And I did this because the FNA is the least invasive form of biopsy a woman can have. It's also the quickest and the cheapest, but right now it's wildly inconclusive, so a lot of doctors refuse to use it. So I created this program, Cloud for Cancer, and deployed it to the cloud as a tool for doctors to use. And the results I got were really exciting. It was over 99% successful at identifying cases of cancer.
Wow.
And I ran it, yeah, it was huge. But I mean, like all good scientists, you wonder, is this just a fluke? I wanted to make sure that the program really was having that much success. So I ran 7.6 million trials. And I proved, yeah, I locked up all the computers in the house for a solid 3 months, setting my alarm every 4 hours, day in and day out, to run new trials.
Oh,
but I proved,
goodness.
yeah, and in the end I proved that as I got more data from the global community, that 99% rate would actually get better and any inconclusives would fall. So I ended up creating this really exciting breast cancer diagnostic platform that, thanks to the kind of publicity the Google Science Fair helped me attain, I'm now beta testing it in 2 different hospitals. I recently submitted it for peer review, so fingers crossed. And I've been able to extend it to work with multiple cancers and genetic expression profiling, so that for things like a very rare form of leukemia, I'm actually able to use similar sorts of algorithms to identify candidates for drug targeting. So there's a lot of potential for Cloud for Cancer, and definitely still working on it.
I'm like shocked by how awesome that is. Like, I don't know if you can tell, but my jaw was like dropping as you were talking. That's so amazingly impressive that you got that. I mean, that's something that they were just completely writing off, that you were able to get that kind of success, and that's so cool. You're awesome.
Thank you. Oh, well, thank you so much.
I mean, all of you guys are so awesome. All of you the campers are amazing here. The guests are amazing here. Thank you all so much for sharing your passion. And you know what? We have these amazing people that are watching that are being able to follow their own passions. Can all of you give us a little bit of advice to how they might be able to get to where you are? So, Brittany, I'd love to hear your advice, and then go on to everyone else about what advice would you give one of the people watching?
So for me, it was just about finding something I was passionate about. I actually got interested in the idea of artificial intelligence completely by chance, by taking this random elective course on the future when I was 11 or 12. And I learned how to code, and my first programs actually learned to play soccer. I was working with game theory, so that was a lot of fun, and I just really enjoyed it. And then as I got older, my passion kind of extended to cancer just by watching those around me, and I really loved just reading articles and trying to figure out how I can make an innovative impact on this field. So I really think it's just about finding something you love, because then it doesn't feel like work and you want to spend hundreds of hours doing this exciting science. And there's so much out there. It doesn't have to be computer science or cancer research. There are so many different disciplines.
That's great advice. Maybe, Mihir, why don't you give us, our campers, some advice?
Sure, so definitely I would echo what Brittany said. And also try to do something, you don't have to follow what everybody else is doing. So like for my project, a lot of the projects in robotics is focused on like trying to use as many sensors as possible, as much computing power as you have, and trying to do all of these really complex things, which is great in some places, but not others. So one of the things that I tried to focus on was sort of using as little as possible and still trying to accomplish impressive results. And so that's sort of something that that's sort of some advice I would give to sort of you don't have to do what everybody else is doing.
Great advice. Definitely, I'm going to take that advice. And Myrijam, why don't you tell us some advice that you would give the people watching?
About my with my project? Or?
Why don't you give us advice so that they can do what you're doing?
Oh, it's just fun. It's cool. I like it. It's my hobby like that. And I will keep doing that. And I hope you all will do what you want to do.
Great. Yeah, just keep following your passion, and exactly like what these are saying. And Arsh, what's one thing that you would tell the campers if they want to be able to be doing what you're doing?
You know, I would like to say, don't be afraid of change and keep making. And I would like to support this with a little example, a little story. Back in the 1950s, IBM came with the IBM 9050. So that was programmed in binary. Back then, no high-level languages, no nothing. So Stan Coley was the first person to come up with the first assembly language, the first language that actually used English phrases. And you know what response he got? John von Neumann said, I don't see why anybody would program in any language other than machine language. John von Neumann was the person who gave von Neumann architecture, which is to date used in all computers. And see where we are now. We're not even using assembly language. We went a step further than that. We're using high-level languages. So if you make something and it's different from others, don't be afraid of that change. It's an invention. It's an innovation. It's your time to change the world, and be proud of that very moment.
That's such great advice. Thank you so much for sharing that with us. And thank all of you for being here. I feel so inspired by what you've done, and I wish you all luck with this amazing science fair. I mean, and everything that you do in the future. Thank you so much for showing us your passions and your projects. And I mean, Arsh, Mihir, Myrijam, Brittany, just thank you so much for being here. And also, campers, we have another hangout coming up after this. And Sam, why don't you tell us?
Absolutely. Stay tuned. We have Arduino co-founder Massimo Bonzi. The Arduino powers more or less, let's say, the entire maker movement and beyond. So stay tuned for that. It should be fascinating. We also have the inventor of Little Bits coming up, Iya Badir. So it's going to be wonderful.
Yeah, I cannot wait. So tune in for the second hangout. And if you were inspired by anything you saw today, remember, campers, do try this at home. Goodbye.
Bye.
Can I say something?
Oh, you know what, Myrijam? Yeah, go ahead.
Yeah, I forgot to say my aim and my hope and my adventures. I forgot this.
Please, I'd love to hear it.
Yes, my adventures are you can link with other people and discover distant countries, and you can get to know much more about their cultures and their ways. And my aim and my hope is you can reduce conflicts with it between people, because this way they because this way they know much more about themselves and about their cultures, about their festivals, and about their scenery. So.
Thank you so much, and I can't think of a better note to end on for the show. So
wonderful.
Thank you so much for the inspiring words, and campers. I mean, you can't get better than this, right?
No, beautiful.
Thank you.
Thank you. Take care.
Bye, campers.
Bye.
Bye.
Bye.